Yes, sir. Good evening, sir. Nirmal Das, sir. Good evening. Nirmal Das, sir. Hello.
Good evening, sir.
Good evening, sir. How are you?
Fine.
Yes, sir. Just open your video, sir. You'll have a look.
Yes,
Yes,
sir.
sir. Yes, good evening.
Good evening.
Good evening. Welcome. Nice to talk to you.
Right.
Yeah. You'll have to talk, meet in person after some time. Yeah.
Yes.
But you did not come to Indian Engineering Congress, is it not? That Delhi, you did not come. If you have come, I would have met. Yeah. Delhi, I came for the Indian Engineering Congress. December I came.
No, I was not there.
Yeah. That's why we did not meet. I met Banerjee sir and other people and all other presidents, our council members. Yeah.
Right.
Okay, very happy. Very happy to see your face.
Thank you very much. Thank you. The first time I'm seeing you, I am also very happy to see you.
Okay, sir. Nice.
Nice to meet you.
So looking forward to associate with you more in future.
Yes.
Really, the topic what you have chosen is a very good topic. The emerging topics today. That's nice. You have tested your PPT and all, sir?
PPT shall I test, sir?
Okay.
Let me share this.
Share it and check it. So that sharing rights is given to you. Just check it. Yeah, it's coming, sir. Okay, sir.
Coming?
Yeah, it's coming. You have to make it full screen. Okay, we'll make it full screen during the presentation. It's not issue.
Full screen.
Okay,
full screen. It's not coming full screen, na?
Full screen only. But I think okay. It's okay. No problem.
It's okay now?
Okay.
Okay. Chalo. Okay.
Okay, sir. So full screen only. No problem.
Thank you.
So we will start at 5:35, sir. People are joining. We will start at 5:35, sir. So it's still time. We'll wait. Okay.
I'll be stopping at 5:30. Nah, we'll be starting at
5:30. 35 will start. 5 minutes will give.
Okay, no problem.
Okay.
Let somebody join.
Thank you. Okay, sir. Thank you, sir.
Okay, sir. Thank you. Hello. বলুন বলুন। ঠিক ঠিক, হ্যাঁ, রাইট রাইট, কলেজ উইল বি রেসপন্সিবল, রাইট 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 রাইট। রাইট, একদম right. ঠিক ঠিক ঠিক, let him study on his own, let him study on his own. একদম, হ্যাঁ হ্যাঁ, ঠিক আছে, ঠিক আছে, ঠিক ঠিক ঠিক। ঠিক আছে, ঠিক আছে, ঠিক আছে। ঠিক আছে, ঠিক আছে, ঠিক আছে। ও বুঝবে, হ্যাঁ, ব্যাস ব্যাস ব্যাস। ঠিক আছে, ঠিক আছে, ঠিক আছে, ঠিক আছে, ঠিক আছে। স্যার আমার একটা লেকচারে ঢুকছি, আমি লেকচার দিতে হবে, আমি লেকচারে ঢুকছি ওয়েবিনারে। হ্যাঁ, 5:55:30-তে। ওকে, আমি পরে 8টার পরে ফোন বন্ধ। হ্যাঁ।
Hello.
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 Yes, sir.
Hello, I'm Lakshman. Hello. Hello, sir.
Yes, sir. Tell me.
Sir, I'm just entering.
Enter. Please enter.
Okay, okay.
Yes, sir. Nirmal Das, sir, shall we start the program, sir? So it's 5:35.
Yes, no problem. We can start.
Yeah, yes, sir. Yes, sir. So I'll let the others join. Let them join in the course. Okay.
Okay.
So happy good evening to everyone. Today we have an interesting topic, that is additive technology, a step towards smart manufacturing, which is going to be delivered in an eminent personality, that is Dr. Nirmal Das, Chairman, Institute of Engineers, West Bengal Local Center, as well as the former Deputy General Manager, SOG, Electronics Corporation of India Limited, under Government of Atomic Energy, Government of India. And also he is a presently professor of International Institute of Management Sciences, Kolkata. First of all, we thank Dr. Nirmal Das sir for accepting our invitation to deliver this interesting topic today to our members. We, IEI Tiruchirappalli Local Center, welcome you, sir, to our program today. We are very happy to receive you, sir. Thank you, sir. Today's program is organized by Institute of Engineers Tiruchirappalli Local Center in association with Kumari Arivial Paravai, Computer System of India Tiruchirappalli Chapter, the Indian Institute of Welding Tiruchirappalli Branch, Indian Welding Society Southern Zone, Indian Institute of Metal Tiruchirappalli Chapter, Indian Institute of Industrial Engineering Tiruchirappalli Chapter, Indian Society of Non-District Tiruchirappalli Chapter. We, IEI Tiruchirappalli Local Center, conduct weekly lecture program for the past 3 decades without stopping. Every Tuesday we conduct program in our BHL campus. Before the pandemic, it was in physical mode, conducted at our IEI Tiruchirappalli Local Center, Dr. APJ Abdul Kalam Hall, situated in our BHL Tiruchirappalli 3,000 acres campus, which was given by the great late Sri K. Kamaraj, then Chief Minister of Tamil Nadu. We, in our IEI Tiruchirappalli Local Center complex, we have an auditorium of 300 seating capacity where we conduct our Engineers Day function, AGM, workshops, seminars, convention, conference, etc. And we also have a library with 4,000 books in the first floor of Dr. APJ Abdul Kalam Hall, lecture hall. We have an office and we have a chairman, secretary, 100 secretary. We have around 2,500 members, corporate members, and 7,500 student members. And our boundary is from Ariyalur, Perambulur, Karur, Pudukkottai, and up to Nagapattinam, excepting Kanjur. We are the role model to the active 10 professional institutions located in our BHL campus in conducting weekly technical programs, other workshops, seminars, conferences, conventions, etc. Our IEI Institute of Engineers aim is to bring the and share the Hello? Hello, I'm audible. Hello?
Yes, sir. Yes.
Yes, sir. Yes, sir. Yes. Our IEI aim is to bring the emerging and latest technologies to our members, students, faculties, industry experts, and to the public and to the society at the large. In today's emerging technologies of Industry 4.0, smart manufacturing, today's topic, additive manufacturing, is a boon. A step towards smart manufacturing is one of the 9 pillars of the Industry 4. So with this small introduction, I call upon our engineer Lakshmanan, our past honorary secretary, presently committee member, to invite the gathering. Over to engineer Lakshmanan. Lakshmanan, sir. Lakshmanan. Hello.
Good evening.
Please go ahead with the welcoming the gathering. Yeah.
Sir, welcome all. Sir, first of all, I welcome on behalf of today's speaker, Dr. Nirmal Das, Chairman, WBSC, IEI, and former DGM, SOG, Electronics Corporation of India Limited, under Department of Atomic Energy, Government of India, Professor of International Institute of Management Sciences, Kolkata. On behalf of Computer Society of India, Tiruchirappalli chapter, Indian Institute of Welding, Tiruchirappalli chapter, Indian Welding Society, Tiruchirappalli branch, Indian Institute of Metals, Tiruchirappalli branch, Indian Institute of Industrial Engineering, Trichy branch, Indian Society for Non-Destructive Testing, Trichy branch, and Kumari Arivial Peravai to deliver a lecture on the topic additive technology, a step towards smart manufacturing. Sir, welcome, sir, for delivering a lecture this evening. Thank you for the opportunity.
Just a wait, please.
Go to Selvaraj, sir.
Yes, sir. Yes, sir. Okay, thank you, Mr. Lakshmanan, for warm welcoming of the gathering. Now I call upon Honorable Secretary Sendil Kumar, Computer Society of India, Tiruchirappalli chapter, to introduce the speaker to the audience. Over to Engineer Sendil Kumar.
Very good evening to all. I am privileged to introduce today's chief guest, Dr. Nirmal Das, Chairman, West Bengal State Center IEI and IEI Council member. Dr. Nirmal Das sir has graduated in Electronics and Telecommunication Engineering from IIEST and he has done Masters in Computer Engineering from BIT, Mesra. Further, he has done MBA Marketing and PhD in Management from SSUTMS. He is a fellow of the Institution of Engineers, India. He is a professor of International Institute of Management Science, a chartered engineer, and a project guide to undergraduate students. He is a visiting professor and he has published many technical papers in national and international journals. As Deputy General Manager and in charge of Education, Electronics Corporation of India, and the Department of Atomic Energy, he has over 38 years experience implementing IT infrastructural projects, automatic surveillance, message switching, campus LAN, EVM, banking automation, and various skill development projects in government departments. He is also a lead ISO auditor. He has served in both central and state government, public sectors, Department of Atomic Energy, Minister of Human Resource Development, Minister of SCST, Ministry of Minority and Banking Insurance, Indian Defence, Air Force, Civil Aviation, IITs and universities. He has served IEI in various capacities. He has served as Honorable Secretary from 2010 to 12, organized highest technical activities. He has organized seminars, national conventions, conferences. He served as a Engineering Division Board member, as a member and also chairman. He received Best Center Award in 2012 by organizing highest technical activities. He remodeled WBSE to have corporate look, auditorium, etc. He has IT enabled West Bengal State Center manpower. He has computerized West Bengal State Center and also implemented tally accounting systems. Currently, he is serving as the chairman of the West Bengal State and is a member of IEI Council. This brief introduction, I request today's chief guest to take over session. Thank you.
Thank you, Engineer Sendil Kumar, for a nice introduction. The stage is given to our Dr. Nirmal Das. Over to your presentation, sir. Please, sir. Please go ahead with the presentation.
Thank you, sir. Thank you, yes. Engineer Balasubramanianji, Chairman of Tiruchirappalli Local Center. Engineer SP Lakshmanan Saab, Joint Secretary. Dr. PR Venkatesaran, Joint Secretary. Dr. Kelvin R. Kumar, Honorary Secretary. And our Selvaraj ji, and all other members, dignitaries who are present today's webinar. It is my privilege to talk on this occasion. In fact, I Mr. Selvaraj or Engineer Selvaraj was a very good friend of mine. And when he told, last time I could not attend because of some personal issues. This time when he told, I thought it's my good privilege, so I should accept this offer. So really, when Mr. Selvaraj asked me, so I thought, okay, let me see whether I can deliver something, some technical aspects, so that both West Bengal State Center as well as Tirupati Center can be benefited. All the members can be benefited. In fact, I am also in the opinion of this. Let us have the cross technical sessions so that we can be benefited by each other and we can have our increase our linkage also. So thank you once again who have come and who have taken the busy schedule and joined this webinar today. Let me start my presentation now. Today, I have chosen a small topic which is particularly known as additive technology, a step towards smart manufacturing. Additive technology is basically, it's very simple technology, but it can do a tremendous thing in future. Let us explore this, what we can do with this technology. Now, I'll be covering very brief on this issue because time is little limited. So let's see how much big inputs or how much maximum inputs I can give it to you so that it can generate a thought-provoking knowledge to you so that you can think on this afterwards, and let's see whether we can go ahead with this or not. These are topics basically you print one small layer, then another layer, then another, like that. If we go on 3D object will be created. So it's basically primitively known as 3D printing. I hope you have aware of this term 3D printing. We are the computer printers you are aware of. So it's a 3D printing. It will be giving it will be creating a three-dimensional object. So 3D printing, also basically known as additive technology, a method of creating three-dimensional objects layer by layer using a computer-created design, whether the material is a plastic or metal or concrete or paper or even human tissues. So additive manufacturing is the process which utilizes the 3D printing technology for industrial production. What it does, I'll tell you in little details. It uses a computer software, CAD, and with this is designed this project or a part, and then by using 3D printer with precise geometric shapes, it will be print layer by layer. So as its name implies, additive manufacturing adds material to create an object without any joints and without minimal post-processing. Normally in our traditional manufacturing, I'll be giving you the difference how it is coming out, but it is traditional manufacturing, what people does, they from a single sheet or anything, they are creating the object and then are subtracting the rest of the material. So a lot of materials are wasted, but in 3D printing or this concept, we will be creating only those areas which will be requiring for the object. Anyway, this is called the opposite of subtracting manufacturing process. Means earlier, as I said, our manufacturing process from a big sheet or kind of thing, you create the object and the remaining thing is subtract. But here it is not subtracting anything. You are putting a small layer by layer till the 3D object is being created. So here post-processing items are very, very less. Although the term 3D printing and rapid prototyping are casually used to discuss additive manufacturing, this process is actually a subset of additive manufacture. So let's talk about the little history, where from it came. In Hiro Kodama of Japan, in their research institute, they have found in the two additive methods fabricating 3D models. The general concept of the procedure to be used in additive printing was first described by Murray Leinster in his 1945 short story, Things Pass By, where he used monochronic plastics. In 1971, John C. Gottwald patented the liquid metal recorder, a continuous inkjet metal inkjet printer. We know inkjet printer for printing our documents, metal inkjet. It will be injecting metal. Device to form a removable metal fabrication on a reusable surface for immediate use of salvage for printing again and remelting. The term 3D printing originally referred to a powder-based process employing standard and custom inkjet print heads, developing at MIT by Samuel Sachs in 1993. The 2010 was the first decade in which metal end-use parts such as engine brackets and large nuts would be grown in job production rather than obligatorily being machined from bar stock of blade. First manufactured by using these project nuts and other things. The United States and global technical standards use this official term additive technology for manufacturing in a broader sense. So let's go a little deep into it, how this happened. It's a program is shown 3D models. Say, for example, we'll be building this process model object. So how normally we will go for the manufacturing process? So for that, first we'll do 3D modeling. Three-dimensional models represent physical body is a collection of points in 3D space connected by various geometric entities such as triangles, lines, curves, surfaces, everything, etc., etc. These 3D models may be created automatically or manually, can be physically created using additive printing devices. We'll see how it will be done. 3D printable models may be created with computer-aided design, CAD software. Is a software with this will be making this design, or via 3D scanner on any object, we can scan by 3D scanner to get the full picture, or by a plain digital camera and photogrammetry software. With this, we can get any object, take a photograph and get the full 3D image. Errors in 3D printable models can be identified and corrected before printing. If any, and the most useful thing is, if you feel that the modeling some error is there, something is not correct, okay, you can change it. Before manufacturing itself, you can have the idea of the model, you can see its correctness, you can see its accurateness, and you can see the model accordingly. So you need not go for the manufacturing process beforewards, where till the model is correct. Now, 3D scanning is a process of collecting digital data, step by scanning, etc., how we have done. And then after scanning, we'll be seeing step by step how this is being created. The technology basically comes into three different categories, broad categories. Sintering is a technology where the material is heated, but not to the point of melting, to create high resolution items. Metal powder is used for direct metal laser sintering, while thermoplastic powders are used for selective laser sintering. Metal powders are used. This is another one technology, one category. Another is melting methods. Melting methods for additives includes power-based fusion, electron beam melting. Metal is direct melted and put it, and direct energy deposition. These use laser, electric arcs, or electron beams to print the objects by melting the materials together at high temperature. So beforewards, actually metal is heated but not melted, but the second category is metal is being melted. And third is stereolithography, which uses photopolymerization to create the part. This technology uses the correct light source to interact with the material in a selective manner to cure and solidify a cross-section of the object of thin layer. The cross-section, etc., all these things by using light source and etc., you interact and get the correct picture and then go for this technology. Now, three basically steps. One is design by using CAD and etc., CAD software, etc., computer-aided design. Then you create a .stl file conversion. The digital model is then converted to a stereolithography file .stl. .stl breaks it down into series of polygons, which represents surface of an object, and the model is then fed to a slicer program or computer-aided manufacturing software that converts that STL file into numerical control programming language, different G codes and etc., through which it directly communicates with the machine and form and print layer by layer, So everything is ready. Now go for the printing. Additive manufacturing processes are broadly classified into 7 categories, each supported by specific material and laser-based technology. So now will be this design has done, STL file creation has done. Now we go for printing, and how printing are done. It is basically done in 3 different categories, 7 different categories. We'll see afterwards. Now see, normally what type of materials we use in this type of additive manufacturing? We can use thermoplastic, we can use metals, we can use ceramics, we can use papers, we can use biomaterials, we can use concrete, so many other things. Now, these printing processes, what we call 7 steps, etc. They are, say, different types. Type 1, hat photopolymerization. It's a technique that machine photograph is shown. Is it decking? Again, it is the additive printer has a container filled with photopolymers resin. The resin is hardened with a ultraviolet light source. And again, it is 2 types of, one is stereolithography. SLA creates a parts layer by layer through the use of a light to selectively cure liquid resin in a vat. SLA is a single point laser or UV source for creating the process. And second is digital light process, the DLP process, that uses flashes single image to each full layer on the surface of the vat. Parts are then cleaned and exposed to a light source to improve the stain. So basically, after the creation, basically parts, excess powder and etc. that you clear basically. And second point is material jetting. In this process, material is applied in droplets to a small diameter of a nozzle, like inkjet printer ink is throwing for printing. From a small nozzle, the material is droplet will come. Similar to the way of a common inkjet printer printing works, but it is applied to layer by layer to build the platform and then hardened by UV light. Third category, binder jetting. The photograph is shown how the machine is for printing. Binder jetting deposits a thin layer of powdered material onto a built platform, after which drops of adhesives are deposited. Layer, then adhesive by printing head to bind these particles together. This builds the part layer by layer. Powders, then some adhesive, then a layer is formed. Then like this, layer by layer. Material extrusion. Material extrusion or fused deposition modeling uses a spool of filament which is fed to an extrusion head with a heated nozzle. The extrusion heat softens and lays down the heated material at set locations, where it pulls to create a layer of material to build the platform, then moves down ready for the next layer. Then powder-based fusion. Here thermal energy such as a layer or electron beam selectively fuses areas of a powder-based form layer, and layers are built upon each other to create a part. Selective laser sintering is often used to manufacture of polymer parts and is good for prototypes. Sheet lamination. Photograph is shown. Sheet lamination involves material in sheets which is bound together with external force. Metal sheets are welded together by ultrasonic welding in layers and then CNC milled into proper shape. And direct energy deposition. It uses focuses thermal energy such as an electric arc, laser, or electronic beam to fuse wire or powder feedstock to be deposited. The process is traversed horizontally to build a layer and stack vertically to create a part. The part diagram is shown how these 7 kinds of printing technology are used to make the 3D objects. Okay. Now, let's see post-processing. So once the part is created, what you should do? Post-processing, like in traditional manufacturing, you have to subtract all these residual parts and wasted parts. But here, very little, very little. Post-processing have 5 major steps like stress relieving, part separation from the supports, post-heat treatment, surface roughness improvement, machining to achieve profiles and geometry. That means surface that sometimes need to be polished, need to be machined sometimes, very little, not unlike a traditional. Okay, the printing time depends on a number of factors. Printing time, size of the part, definitely size is bigger, printing time will take long time. Setting, use of printing, whatever the setting or arrangements will do, based on that, printing time and quality of the finished part. If you want a post quality, printing can be done very easily. If you can have fine quality, then everything should be taken care minutely and printing will take little more time. Okay, so basically speed, resolution and volume of the part, the printing time depends. Now let's see what are the benefits we can have with this additive manufacturing technology over the traditional manufacturing. It's a cheaper for small production runs. For small production, it's very cheaper. Anytime anybody wants to make a small part, so and it's a very easy. I can tell you. Tomorrow, see remote place, Tiruchirappalli is the local center. I think it is far from the metros. So if I need to supply some spare parts, then spare parts required. So again, it has to travel all this way from metros to that place, and I said, suppose the imported parts. It comes to the metro and then from abroad, and then it will go to the Tiruchirappalli station, and then from there actual customer. If you have the printer, and if the materials is create, you can create very easily. It's a cheaper small production for small production, more customizable, more adaptable. Whatever the items you want, so you can customize anything you require, and you can adapt anything. No added cost per complexity. Now, if it's a complex part, kind of thing, say complex part, there is additional cost. You make it 3D design, right? Make it STL file, and then you do it. Printing like that. I'll show you the program how it can be done. Get the product fast. The product can be obtained very quickly. Avoid waste. Most things. You can reduce waste like anything. And reduce cost of failure means enhance innovation. When the failure costs are less, you can go innovation day by day. More innovation, more innovative idea. But still, there is a little glitch still today, because competitive pricing for production in large quantities still not assessed, right? For large quantities, how it behaves. The use of certain materials and technical considerations is an issue till today. Perfect finish means machining and smooth machining. Of course, after having the printout, you may not get the 3D by perfect finish. Maybe you have to go for a little machining kind of things, and large scale manufacturing still today is an issue. But I believe this new dimension and new technology of this manufacturing process, and over time, this problem will easily be solved, can be solved easily. Now let's see. We have seen the technologies, we have seen the additive printing. Let's see who could be the user of this technology. Who could be the benefited for this by using this technology? Medical industry, aerospace, any complicated parts of aerospace industry can be made in this. Medical industry, see the detailed models of organs. I believe human organs may be created by this process. Using multiple 2D images, slices, and MRI CT scan by this process, you can create you can emulate this 3D dimension of the object, and you can do it. You can believe movie industry. By using this technology, you can have any three-dimensional animation film. Science sector, architecture industry, archaeology community, engineering community, and even the art science community. These all communities people are using this technology. We'll tell you, we'll tell you how these communities are being benefited. If you see the applications and advantage, a small idea is given: industry, aerospace and defense. These applications, these advantages: automotive applications and advantages, electronics applications and advantages, healthcare applications and advantages, consumer goods, and agricultural goods. Now, I also got surprised when I came to know that even the food industry, chocolates are being manufactured or being produced by using 3D printer. Can you imagine? Human heart, human lung are being manufactured in medical industry. Dentist and this eye, the specs are being manufactured in this technology. See some applications, you see auto parts. The Audi RS2 was made with rapid prototyping industrial cooker robots. Just imagine. 3D selfie. We are very much fond of making the selfies, right? So all this mobile, we are getting the 2D selfies. Clear? So we make a 3D selfies. Take a 3D camera, take 3D selfies, and you can build your own image, own prototype. You need not call for any archaeology or any other persons who can manufacture this, architect and etc. etc. You can make your own body, own selfie by using 3D printing. 3D printing is jet engine model. You see, this engine is printed by this. Cockeries, necklace, ornaments, jewelry industry, sculptures, all are being used by using manufactured by 3D. Additive printing is changing auto manufacturing parts. All these manufacturing parts can be generated, can be created by using additive manufacturing. Concrete, building. You can't imagine building can be made using additive manufacturing process. My goodness. 3 ways additive printing is recognized as digital dentist. Shoes, lenses, printing lungs, additive printed lungs. By using human tissue, you can create this lung. So these are the applications we have seen. Well, now see what are the advances in additive technology. Can you imagine this bridge is made by using additive technology? An additive printed concrete pedestrian bridge developed in Tsinghua University, by Tsinghua University. This concrete bridge is manufactured by additive technology, additive concrete technology. Okay. Now let's see the market trend. Market trend, if you talk about this market trend, 2019 undoubtedly was an exciting time for additive printing. The industry continues to move towards industrialization, and technology is increasingly becoming a part of wider manufacturing ecosystem. Global usage of additive 3D printing is shown like this. You see, US, UK, Germany, France, China, Mexico, Japan, Switzerland, South Korea, Netherlands, Italy, Australia. These are the leading countries who are using this additive technology. This is the global spendings. You see, in Asian additive manufacturing market size, US 36%, Asia 28%, Eastern Europe 26%, and others 10%. And out of this Asia, China, Japan, South Korea, Asia, and Australia, and India. India is using only 5%, but China is the leading around 50%. So India has just started this technology and hope we can go ahead long with this technology. If we talk about the manufacturing market share, say, growth path of global additive manufacturing market, how is it growing? In 2027, it is expected to be $41.09 billion US. Okay, chalo. Let's see what are the advancements are going on in this area. Ongoing research areas in additive technologies across the globe. See, Oak Ridge National Library. Researchers demonstrated that cooling cost saving could be achieved with a additive printed concrete smart wall following a 3-month field test. Smart wall they can make using this additive printing. They have developed artificial intelligence software for powder-based additive printers that assesses the quality of parts in real time without the need of expensive characterization equipment. I told you in little before slides that machining and the quality, still some certain issues are there. See, researches are going on how to make better quality materials. Lawrence Livermore National Library. Scientists and engineers take advantage of additive printing and are making flow through electronics, 4 components of electrochemical reactors. They have developed a new method for our additive printing living microbes in control patterns, expanding the potential for using engineered bacteria to recover rare earth metals, clean wastewater, direct uranium, etc. Detect uranium, etc. can be done by this. They use multi-material additive printing to create tailored gradient diffractive index glass optics to make for better military specialized eyewear for virtual reality goggles. This in other areas. Fluid surgeons may soon be able to localize critical regions in tissues and organs during a surgical operation by a biosensor that can be created in 3D automated printing system. Manny Fisher teams built additive printer during a week-long robotics camp at Sandhya National Laboratory last year and have used them to make more than 3,000 face shields for medical professionals in New Mexico. Face shields have been created by using 3D printers or additive manufacturing process. Researchers have utilized additive printing and nanotechnology to create a durable, flexible sensor for wearable device to monitor everything from vital signs to athletic performance. Tel Aviv University researchers have achieved a major breakthrough by developing a biological personalized bioink and producing the first ever additive printed heart. I was talking about additive printed heart. Researchers at the University of Minnesota have developed a unique additive printed transparent skull implant for mice that provides an opportunity to watch activity of the entire brain surface in real time. So they have created a mice, skull of mice, and see in the real brain how it matches, how it can adjust with this printed skull. New additive printing techniques could allow researchers to create artificial tumors to test new drugs and therapies, ultimately leading to better and more personalized medicine. So from the before operating itself, we can analyze which type of drugs it can be appropriate before operating the tumors. So we have seen the application areas, how the research is going on. Let's see the materials contents. Whatever the materials are being used, let's see in this area, what are the research going on? Okay, materials. This enables engineers and designers to easily test new materials, depositing them deliberately a particular point to space to build any scale structure and either validate or eliminate the result. They'll be using different materials and see how it can, whether it can shoot to create any other new object or not. Electronics. A research collaboration from University of California, Santa Cruz, and US Department of Energy, Lawrence Livermore National Laboratory are using 3D printing to improve supercapacitor electrodes, which are used as energy storage devices because they can charge very rapidly from seconds to minutes, can retain storage capacity through tens to thousands of charge cycles, particularly for electric vehicles. Now, you know, I think you are aware that slowly the world is getting more and more electric vehicles. These are very much useful for electric vehicles. Medicine. It may someday revolutionize medicines, potentially giving us the ability to print tissue and possibly even organs for use inside the human body. A team of engineers from the University of Colorado have created a new method to 3D print while maintaining a localized control of an object's firmness, with the ultimate goal of 3D printing artificial arteries and organ tissues. The new layer-by-layer printing techniques feature fine organ programmable control over the object rigidity, enabling researchers to mimic the complex geometry of blood cells that are highly structured but need to remain malleable. So, in this medicine area, these results are going on, and definitely we are going to build our tissues and organs inside the body. Innovation is opportunity developed through partners, researchers and universities of Northern Texas, Iowa, Pittsburgh, Louisville, and so on. This area evaluating ceramic 3D printing for dental, fabricating and evaluating compositionally graded ceramic for metal parts and etc. and so on. So these global research and etc. are going on, and I believe definitely it will be near future. We'll find lot of things are being generated by using this technology, and particularly in healthcare and medicine sector and other sectors, of course. So, as I told you, research in areas where the people are, things are going on, etc. See, the companies, how they are spending a pattern of R&D expenses. See, General Electric, HP Incorporations, Autodesk, like these, so many other companies, they're spending patterns, you see, on R&D. In fact, I can tell you, HP, they have generated new 3D printer which can print very easily. So researchers are spending a lot of money to adopt this technology in the near future. So let's see, with this thinking, with this research and etc., what is going to be the future end of 3D printing technology? The year 2019 undoubtedly was an exciting time of additive printing. Why? The industry continues to move towards industrialization. The technology is increasingly becoming part of the wider manufacturing ecosystem. The trends of additive 3D printing is estimated like additive printing will become the mainstream technology for serial production. Of course, you know it is serial production. Otherwise, if you want to go to parallel production, then you have a lot of big base of the printer, you require printer base. Design software for additive will become more integrated and easier to use. Researches are going on. Focusing on education will elevate more 3D printing applications and adoptions. Dental will adopt additive printing as a dominant production technology. Additive printing will become smarter. More smart printers will be getting slowly. Additive printing service bureau market will continue to expand. Metal additive printing will continue to mature. Composite additive printing will offer a huge market opportunity. Automation will become a key focus for the industry. additive manufacturing landscape will become more competitive, and ultimately we will be moving towards Industry 4.0 with the smart manufacturing. The future trend we are expecting will come slowly. What we can have Vision 2050, what we are going to. I'm definite by Vision by 2050, all manufacturing process will have smart manufacturing technology. Whether you use artificial intelligence or whatever, definitely it is going to have smart manufacturing. The changes to construction, engineering, and maintenance will be fundamental by 2050. So construction and engineering, these two sectors, this manufacturing, the additive manufacturing will sweep like anything. That is our vision. Artificial organs have already appeared at research level. The isolation of stem cells made the construction of any body cell is possible in the future. Genetic engineering enables screening for genetic disorder. By 2050, we may be able to create genetically perfect people to determine even the insect features like teeth, height, hair color, eye color, etc. All this can be corrected. So we can have genetically perfect people. We are expecting by 2050 we can have genetically perfect people in everything is okay in every respect. By 2050, 3D printers will be present in our home. It's too true. Today, I think almost all the people who are basically using this computer, laptop, and etc., having their own printers. So after another 25 years or something like that, yes, we expect all 3D printers will be people will be having at their home. By 2050, additive technology will open up the huge perspective for applying it in the industry, medicine, and or education. Definitely. All medicine, etc., medicine production, and the education particularly, I'll show you how it can help you. Additive printing in the classroom. Let's see how additive printing can help us in classroom. Additive 3D printer will definitely change the teaching style, coursework, or lesson plans. How? Let's see how. Additive printing allows educators to design rich learning experience for deep theoretical constructs. That's learning from computer screen into students in hands. From computer screen, what I see, I can give you in hand, 3D model. You see how it is. Digital 3D worlds come to life with 3D printer, which can encourage sharing, teamwork, planning, design, and thinking through difficult or complex ideas. Instead of 2D image, if you see 3D image in front of you, we can have generate a lot of ideas. Complex ideas, you can create a lot of complex ideas. It will be easier to think. People can think more and more in advance if he or she gets a 3D object in his hand rather than 2D photographs. There is an array of uses for additive printing across academic disciplines. Like, just imagine, biology students can print organs, chemistry students can study 3D printed molecules, graphic design students can create 3D versions of their art, history students can print historical artifacts, architecture students can print the 3D models. 3D printing prototype provides practical hands-on knowledge for understanding, ideally suited to project work, common teaching practice in science and mathematics. Use of 3D printers will promote thinking, reasoning, and understanding. Just imagine every types of discipline or areas of education, you can place this on your own. Architects, history. Either you have to go to that particular place, historical place, or you can stay on the book this photograph. That's all. Here you can create the image and then see how the archaeology was there, how the civilization has grown up. Biological. So instead of medical students, say, for bringing this, human skull or bones and stuff, you can artificially create this and you can see easily n number of times. You need not wait for a dead body. Science. Can you imagine to get a 3-dimensional bodies of molecular this thing? Maybe few schools are there, few English medium schools are there, they may get some small models to show their children. But you see, maximum school, they do not have the 3D models. You can create your own model. You can give the full idea of the molecular structure. You can give the full idea of the common architecture, common structure of the building, how it will be. Science department can use 3D printer to build models for teaching, such as molecules, eyeballs, cells, sine waves, 3D sine waves, to build components. Work in mathematics emphasizes developing people's 3D visualization skills. Now, whenever we have done in engineering drawing, initially, any object, we have to imagine by using a plan, elevation, endpoint, end view, side view, top view, all these things. You can imagine the 3-dimensional figure, what are the bore is there inside or not, what the nut was there. So we can imagine from the plan, elevation, top view, front, bottom view, side view, etc. Lateral side, right side, etc. We can see. Now you can see the topic of the project or prototype thing is available in 3D in front of you. So how easily you can understand these things? People with poor concentration, people normally who get bored in these photographs and etc. Who get bored in this mode of teaching or learning. If you make them a small object in front of him, he'll be very much interested to learn. Hey, what is this? This improve academic learning, particularly poor concentrated people who are not getting interest in traditional concepts of that. You give any object, anything like that. So many things are available in today's learning. No, flashcard method for English, tense and etc. Like that, you can create a model with 3D printing, and the people will be concentrated on the same question like anything. How additive printing is useful for the society? Increasing mass personalized production will take a turn towards local. That means this production part, basically, instead of massive global, it is turning towards localized. You can manufacture your own requirements. Medical world will be turned upside down. Everything will be changed. If you start manufacturing this organ with 3D technology, everything will be changed. Everything will spark a creative renaissance. Could help solve the housing crisis. There is still problems are there. I know the story, it came in the paper that China, during the COVID time, they could build a hospital, big hospital in 3 or 4 days time or something like that. Maybe it was pre-constructed walls and etc. they have used. But imagine the case of 3D printing technology. You can easily create your own buildings like anything. Making replacement easily accessible, helping the disaster relief, making construction simpler and cheaper, affordable school facilities, well-organized transportation, printing your own food. Most important thing. You can print your own food. Can you imagine? Can you imagine today? You can print biscuits, you can print chocolate, you can chocolate industry. In fact, abroad, chocolate industry is using this printing technology. You want to have some chocolate, print it and take it. Bioprinting organs, archaeological, cultural preservation, sustainability. Archaeological things have lost, say, for example. So you can build your own archaeological by printing and put it in. I think you have heard the story that our Rabindranath Tagore's Nobel Prize, that Nobel medal, which was displayed in his birthplace Santiniketan, it was lost. And ultimately, lot of CBI, everything is over, but ultimately that particular medal could not be found. So what we can do? We have a photographs on this. If we can create some more 3D photograph of this Nobel medal, you can easily create a second medal and you can put it in the display. Well, let's see. Technologies by proportion of companies likely to adopt them by 2020 to 2020 projected. See, in this year, the projected companies expenditure, user and entity big data analytics, etc., application and web-enabled markets and etc., like the 3D printing comes in this stage, 41%, almost 50% of the total expenditures, I mean highest expenditure. So it is slowly gaining, and it has got a appreciation, a remarkable position. Definitely is going up like that. Now let's see what our India is taking this initiative in this technological area. India has generated considerable interest in the Indian manufacturing ecosystem, and the platform has been laid to support tremendous growth. Initiatives are undertaken by various stakeholders to develop a domestic additive manufacturing ecosystem in India, along with government-led efforts. Government has taken some steps. vis-a-vis, or some private peoples are also coming up. They have taken some initiatives. Let's see how people have taken initiatives in India. Establishment of additive 3D printing manufacturing lab at National Institute of Electronics and Information Technology, Aurangabad. They're going to establish one lab. Otol Innovation Mission, under the aegis of this, Otol Thinkers Lab, 1200 to 1500 square feet dedicated innovation workspace have been set up where do it yourself. Kits on latest technologies like additive printers, robotics, Internet of Things, IoT, miniaturized electronics are installed through government financial support of 20 lakhs so that students can grade 6 to grade 12 can tinker these technologies and learn to create innovation solutions. So see, along with this robotics, we are hearing a few sometimes back. Internet of Things, very recent technology is coming up in electronics, and along with these, additive printers also come into taken its place, so that people will be having this work, do your project yourself by yourself by using this technology, where additive printer has already taken a space. Gujarat government has signed an MOU with the US Institute of 3D Technologies in California and OEM 3D Systems, a leading global 3D printing companies, for establishing 7 3D printing centers of excellence across 7 engineering colleges and technical institutes in the state. 7 3D printing centers of excellence that are going to establish in 7 engineering colleges. Andhra Pradesh of MedTech Zone collaborated with University of Wollongong to set up a 3D bioprinting lab. So states are coming up, Indian states. 3D printing, what the news says, what the government decided in the parliament, business standard first published in Thursday, February 24, 2020, ensuring manufacturing leadership in the 21st century according to the Ministry of State for Electronics and IT. India is ready to build and lead in additive manufacturing space. They have taken this as in one of their agenda. Government aims to add nearly 3 billion to GDP in 3 years from 3D printing. Imagine. It aims to capture 5% of the global market share in additive manufacturing. So, it's planning to capture at least 5% of the total global market share. This strategy aims to create 100 new startups, 500 additive manufacturing products, and 50 Indian additive manufacturing technologies on material, machine, process, software, and so on. Under the national strategy on additive manufacturing, the government plans to create 50 India-specific technologies for materials, machine process, and software to make India 3D printed design and manufacturing hub. So government is having in mind to make India a 3D manufacturing hub. Well, government is targeting 50 new India specific technology, 100 new startup, 10 existing and new manufacturing sector, 1 lakh new skill manpower. Mind it, government is planning to have 1 lakh new skill manpower. So around 1 lakh new job is going to be created in this area in India. The 3D printing has got a lot of scope in making artificial limbs, stents, dental crowns, parts of automobile and consumer goods and so on, already discussed. Key goals of Indian 3D additive printing policy: establish India as a global hub for additive manufacturing, to develop and safeguard India's additive manufacturing intellectual property. The government will focus on promoting ease of adoption of additive manufacturing in India by introducing policy intervention on a regular basis that provide enhancing manufacturing capabilities and encouraging foreign technology manufacturing in India, encouraging and incentivizing indigenous manufacturers who promote a sustainable additive manufacturing ecosystem on a national and global scale, encouraging machine, material, and additive produce coal, goods and services, export and re-export, and discouraging imports for domestic additive market. You make your own. Already, present government has taken a decision, make your own product, right? Make in India, and now it is make your own. You make your own product. So from this strategy, we found out 50 Indian specific technologies newly planned, 100 new startups, 500 products, 10 existing and new manufacturing sectors, 1 lakh new skill manpower, awareness for adoption of additive manufacturing. People are going to be aware by this government policies to be adopting more and more additive manufacturing process. Policy recommendations: establish new dedicated agencies such as National Additive Manufacturing Center to separate the national initiatives, enhancing technology leadership through talent, R&D and supply chain management development. Government to include additive on the popular scheme like credit link capital subsidy scheme for technology improvement, lean manufacturing competitiveness scheme, technology and quality improvement support for SMEs, software product innovation development scheme, production link, etc., etc., etc. So government is trying to, Indian government is trying to promote this additive manufacturing like anything. Their policy also recommends that a lot of incentive schemes they are going to introduce in this sector. Let's see from the government, let's see other initiatives what they are going to have, are being happening or going to have in India. 3D printing technology is changing the construction landscape in India. It's a business standard report on April 6, 2021. L&T construction could disrupt the reality space with 3D printed house. The news came in February 9, 2021. 3D printed construction startup has to receive 3 crore investment. It is an IIT Madras Incube started in 3D printed home segment. Information received on October business standard. Indian biotech engineer is on a mission to create human organs using 3D technologies. Reported on March 20, 2021. Apollo Hospitals to establish 3D printing labs for printing of implants. February 17, 2021 news. Pawnikul Cosmos fires a single-piece fully 3D printed rocket engine. These initiatives are being taken up as per the information by business standard. Hindustan Aeronautics Limited And Wipro 3D signed an MOU for metal 3D printing in aerospace. Gujarat adopts 3D scanning and 3D printing technology to investigate serious crimes. Obviously, if you investigate through 3D, then apart from only photographs or painting of the photographs of the criminals, it will be more easier. You can create this person. Proudly made in India, immigration PPE goes aggressive against COVID-19. They have made PPEs. India also made PPEs. Anatomized 3D develops cost-effective 3D printed face shield for COVID-19 protection. India's large 3D printing farm divide by zero. Steps of effects of fighting COVID-19 pandemic by making this face shield and these masks. Wipro 3D in collaboration with SCTIMST launching AirBridge, an emergency breathing assistance system. India's space tech startup Skyroot Airspace unveils 100% 3D printed Dhawan-1 rocket engine. WebTech Corporation inaugurates India Additive Manufacturing Center in Bangalore. Fast Track Management Consultant and Manufacturing 3D announcements, strategic alliances to serve as a catalyst in building 3D printing ecosystem in India. These are the non-government areas where initiatives are being taken in India. Scope of small sector India, small scale industries and employment opportunities. Additive 3D printing manufactured in India. This printer can be manufactured. Printing service can be given. 3D companies can be built like this. Additive 3D career opportunities in India. A lot of careers that 1 lakh new manpower already government taken up that policy. Already these areas 3D printer engine, 3D printer operator, 3D printer engine, jewelry, CAD designer, computer design, designer, computer design, CAD design, industrial design, all these areas basically we can have skilled manpower in near future. Okay, these are the areas where defined of jobs we're expecting in near future. 3D design job, research and development, construction modeling, CAD modeling, biological modeling, and education. Okay, some of the popular companies that are looking for 3D printing designers, these are the areas where jobs are available. Of course, you can search net, you can get this. What are the 3D printing jobs available? 3D companies in India, lot many other companies, particularly I've seen in Bangalore area, Gujarat area, companies are coming up. In Calcutta area also is less is coming up, but less. Job opportunities in India, 3D printer operator, engineer operator, animation, sales support, right? Internship program, we are going to have R&D internship program, all these things. And government is expecting the emergency package should vary around 2.8 lakhs to 5.5 lakhs to start with. Apart from this, you can have entrepreneurship development. 3D printing service provided offers all types of 3D printing related service, including supply, 3D printer manufacture. Some of the additive manufacturing companies in India already I told, 3D printing filament, resins manufacture. You can have your own company. Okay. 3D printing accessories supplies, 3D printing education initiative to run the trainings and courses, 3D selfies, modeling, all this. That means these are the areas. If somebody wants to build an entrepreneurship, he can try for. Well, now let's see key points. We have come almost end of this presentation. Let's see what we have learned today. Additive 3D printing is a unique example of technologies and manufacturing working together to become more sensible, sustainable, flexible, and responsible, ensuring enhanced efficiency and quality. 3D printing helps industry think faster, innovate better, broaden up the horizons of manufacturing, and produce what one could imagine. Whatever you want to imagine, you can produce. Additive 3D printing in India has the potential to become $1 billion industry in coming years, as per Santos Kasru, Director of Fast Track Management Consulting. As according to him, $1 billion industry is going to get in coming year in India. Additive 3D printing industry needs to work together and focus more on increasing market awareness and creating new market segments. We still have very low penetration in various industry segments compared to global penetration, but holds the potential of becoming $1 billion in coming years. As he said, over the next few years, engineering, industrials, toolings, education, medical, and aerospace and defense segments should exhibit promising growth in Indian 3D printing market. Additive 3D printing or additive manufacturing uses computer-aided design to make prototypes of working models of objects as per parallel dated December 12, 2020. 3D printing market to reach $51.77 by 2026. Additive 3D printing plastic market will grow at a CAGR of 24.6% by 2027. As reported, Government of India plans to promote 3D printing to enter the global market, as already discussed. So now I conclude. So if we talk about the industry 4.0 smart manufacturing, what is that? It is nothing but a new version of intelligent manufacturing. This smart manufacturing is nothing but an intelligent manufacturing system, reflecting the magnitude and impact of smart technologies such as that Internet of Things, cloud computing, cyber physical systems, big data, and so on. Adoption of 3D printing technology is suitable for promoting and is now rapidly transforming into production technology, right? So all these things, you can have this design part, and if you can adopt with 3D, definitely will be achieving actual smart manufacturing techniques and technology. The additive manufacturing policy for India is imperative to give space with technology. Identifying additive manufacturing is likely path for development and devising student strategy to navigate the path for future economic growth. Partnership with industry bodies like Additive Manufacturing Society of India will be encouraged to address the industry needs effectively on technology, design, software, material, machines in India. 3D printing and additive technology is therefore a stepping stone towards smart manufacturing with improved manufacturing performance on Industry 4.0. I'll conclude with a small video. Please bear with me. Please bear with me.
What is additive manufacturing? What is additive?
Is it visible? Screen is visible, sir?
Screen is visible, sir. Screen is visible. Audio is not coming.
Additive manufacturing, also
Visible?
Yes, visible, sir.
Object from a digital
Now it's okay, sir. Now it's okay.
An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the
how
first
the layer
layer
is
of
being
3D
formed.
design. The platform is lowered, and another layer of metal powder is spread across the platform.
Second layer is being manufactured.
The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
One more video, please. Sir, is it visible? Sir, is it visible?
Yes, it is visible.
Now it's visible, sir. Now it's visible.
These are real machines.
Additive manufacturing.
The metal,
3D printing
metal plate.
are general terms encompassing a variety of systems used to create three-dimensional physical parts and models directly from digital data.
See how the layers are being printed.
Primarily manufactured using a layer-by-layer or additive means of construction.
Ask one question.
What's that?
Remove, sir.
Additive technologies are based on the solid modeling portion of computer-aided design, or CAD. Additive systems use the solid modeling
How the different parts are being
extremely
printed.
thin cross-sectional layers.
Metal,
This permits
metal part.
manufacture of intricate and complex shapes and surfaces much more simply than by conventional methods. Pieces can also be built from three-dimensional imaging data generated by 3D scanning or medical imaging devices. Materials used in additive manufacturing are broadly classified as either liquid, powder, filament, or sheets. Polymers are the primary type of materials used in additive manufacturing. But systems are available to build with plaster, metals, silica sand,
Silica sand,
paper,
building this paper.
ceramics, and even biological materials.
Biological tissues, you see.
Additive systems range from large industrial machines suitable for shop floor and laboratory environments to smaller desktop printers used by consumers. These systems utilize numerous technologies, with the most popular including vat polymerization,
The printers, already
powder
discussed.
fusion, material extrusion, and material
jetting.
jetting. Although additive technologies have been in use for decades, new advancements and applications are being developed every day in the fields of aerospace, industrial machines and tooling, medical implants, surgical guides, home decor, art, and so much more.
Well, now I have completed this. Now, if anybody is query, you can answer.
Yes, sir. Really, it was a wonderful presentation, sir. Thank you so much. Really, we enjoyed your program. Nice. Really brought the all governments of 3D printing and government policy, how the industry is going towards future and all. You told about 1 billion US dollar like that is going to be emerged. What is the present turnover, sir? 3D printing in India?
Sir, I'm not getting you fully.
Fully. Okay, okay.
Just a minute.
So you told $1 billion
Just a minute, sir.
is going to be.
I'm making Just a minute, sir.
Okay.
Sir, tell me.
Yeah, you told that $1 billion is going to be emerged as a business in 3D printing shortly.
What is that?
$1 billion turnover. $1 billion turnover. What is the present turnover, sir?
What is that?
Present turnover. Present,
No.
right now.
Present turnover already showed. It is something like this. 3 point percentage, exactly figure I don't know.
Okay.
It will be around 0.2 to 3 billion. 0.2
Okay,
something
okay.
like that.
Right, sir. Thank you, sir. It was a wonderful presentation, sir. Thank you so much.
Achha.
Yeah, yeah. We enjoyed. So participants can ask questions. Yes, sir. Now session is open for the questions. Yeah.
Okay.
Yeah, good evening, sir. Myself, Sai. I am a research scholar. I am working on additive manufacturing, wire additive manufacturing. So I have one doubt, sir.
Tell me.
Sir, in VAM, when we reduce the weight of the component, I'm not talking about powder-based additive manufacturing. I want to only VAM, sir, wire additive. If we reduce the component weight,
Sir, your voice is not audible. Please be louder, please.
Sir, I'm audible, sir. Is my voice?
Tell me, please repeat once again.
Can we reduce the weight of the component by using this wire additive manufacturing process? Is it possible?
Now, what is your question? Just 1 minute. Sir, just 1 minute. Tell me.
Is it possible to reduce the weight of the component by using VAM process, wire additive manufacturing process?
Hello. Tell me, sir, please, sir.
Sir, is it possible to reduce weight of the component by using wire additive manufacturing process?
Yes, sir, I'll tell you. Now, weight of the component if you want to use, it depends on the material. Now, if the particular part, say, it is useful for some other machines and etc., right? And if you feel, and if the parts manufactured by paper can be suitable for there, because ultimately whatever you printed and etc. by the adhesive and etc., it's a paper material only. So paper with lot of water and etc., it will be damaged. Understood my point? Huh? So if that particular paper material object can be utilized like that, instead of ceramics, you can make by using paper. You can make the cup. Okay. Now with that paper cup, normally what we take in paper cup, tea or coffee, simply 1 or 2 use and throw type is possible. So if you want to make it reuse, then it has to be porcelain, ceramic kind of thing. So if you use ceramic, then how this weight will be coming less? Maybe what you can say, the thickness of the cup or this, maybe in ceramic, it is a definite. By using this technique, you can make it very fine, very thin. By making it, you can make it. If thin cups and etc., thin parts is suitable for your machines, etc., utilize this, you can do it, no problem. So other materials, whatever you use, you can use anything by using any material, right? And the basic material, if it is using by fitting to that area, you can use it, no problem. So by using this, you can reduce the weight. Now, say if you want to make the building structure, right? The building structure, by making it full concrete, you can make it a hollow type of thing. But only thing you have to measure engineering point of view, whether it can withstand the pressures and loads and everything or not. If it can withstand, you can take it. You can reduce the weight. You can reduce the weight of the bridge. Tell me, sir.
Okay, I accept whatever you said. That is only suitable for the powder-based manufacturing. Actually, I am talking about wire-based wire additive manufacturing. So whatever you said, ceramics, polymer, we can use hollow type of components.
Normally, you see, in our high-rise building, people are using nowadays hollow bricks, isn't it? So that way you can do it.
But whatever you are saying is correct, sir. Asking, for example, if same dimension, same geometry, taken on aluminum component is compared to cast or wrought alloy, wire based only VAM, wire additive manufacturing, not powder based. The wire based can be reduced or not. It is possible to reduce.
Definitely.
நான் சொல்லிடுறேன். கழுதை வந்து என்னத்த போய் நான் நேற்று அம்மா
It is possible to reduce provided it fits your requirement. You can reduce any. You can.
அதான் அவருக்கு கேட்டாங்களா அவங்க வந்து அவர் மேனேஜ் பண்ணிக்கிறதுனால விட்டாச்சு. நம்ம கேட்கற நம்ம கேட்டாச்சு.
Yes, sir. Sir, any more thing?
Sir, actually, it's biological. Sir, I am Lakshmanan. Sir, biological tissue is manufacturing using 3D printer. How this can be integrated with the body, sir? Physical body.
But see, it's the function of doctor. Only thing I can tell you, this biological heart or lung, that will be printed by using tissues only, cells only, right? Maybe you'll be collecting some cells and then you will be creating this heart or lung. And then whenever this particular heart or lung is created, right? And probably in newspaper it came, in somewhere they have used some artificial heart. So now the doctor has to see how it's matching, how body accepts this artificial heart or artificial lung. Similarly, this 3D printed category heart and lungs, of course, it is not artificial, means it is made by created by tissues only, but it is the doctor, medical science will see how quickly it can adopt, body can adopt. That part is still questionable. Questionable means that part yet to finalize. But the thing is like this: you can easily create the stain, you can easily create the nerve, blood vessels. You can easily create the some part of tissue that is already created, and by this process, I have no information so far, no data so far, whether it is actually fitted into the body. But things like this, as it is created, it can be created, and the medical wise it found that it's functioning well. Tomorrow it can be fitted to human body and see the result. So these are another source. Instead of putting, say, I'll tell you, pacemaker. So what pacemaker does, it is all together you are going to put an electronic instrument inside the body. Am I correct?
Yes, sir.
Instead of putting a third party which body never accepts, sometimes it happens. Instead of putting a metal body inside the body, if you put a part by creating by tissues and cells only, better acceptance will be there definitely. Now I don't have this actual data available whether this heart or lungs so far fitted into the human body or not. But definitely it is after research, people have manufactured, they have created, and it's yet to be tested further. And I hope by 2050, definitely these things will be done by this time. So it is a big area can be explored in coming 20-25 years.
Sir, another one question, please, sir.
Yes.
Sir, mask identifying an individual can be made by 3D printing. How this can be? How we can identify the real face? One is wearing another face mask. How we can identify who is original, who is wearing a mask?
Oh, I mean, if you want to create your own mask in your own printer, am I correct?
Yes, sir.
The question is, if you create your own marks on your own printer, how can I identify it's original or create or duplicate,
yes,
something like that, right? See. How will create marks? How will get face marks? It's made of plastic kind of things. It says that face mask, what is there? It's kind of plastic, it's a kind of thing. So you have to manufacture by using plastic, and you may be using different kind of plastic. You may be using papers. Doesn't matter. Now whatever its parameter, if it is as per our government norms, if the parameters are accepted, okay, government will allow you. Whatever the government norm during COVID time, that face marks and that face marks and then what do you call that this thing, people have generated and ultimately it's approved by the government and government allowed it. That's why. So if you want to make it mass for production, then you have to definitely it has to be tested by the and get it certificate from the government. If you want to use on your own, it is up to you. That you have without testing whether it's really protect germ or not. It is up to you. Today many people are not wearing any mask. It is up to them. They are taking the risk. Some people are wearing masks. They are up to them. They are taking the protection. So tomorrow, what the masks you have manufactured on your own printer, if you are wearing it is up to you. If you test it thoroughly through the testing process, then you can declare that my mask is having so tested and it is protecting 99% germ or something like that. 99% like that. So then you can demand and you can say you can contribute to somebody that you take this mask. Right? You can have the data, tested data. So unless you test the data, you can wear your own. That's all.
Thank you, sir.
Thank you very much.
Thank you, sir. Really, it was an excellent talk by you, sir. We enjoyed your talk. Thank you so much. Very good evening. We had a knowledge team of leading. It was able to grasp the latest techniques from you. Thank you so much.
Thank you very much.
Yes, sir. We'll move to the next agenda. If you have any more questions, we'll move to the next agenda. Next agenda is next week's, program. What you have planned is just actually my secretary held up in a meeting. Next program. Next program is the topic is going to be improvement in free weld, post weld using heating solutions. SWAT accelerating gas junction outcoming CapEx connectivity. The talk is going to be given by an expert speaker. His name is Dr. Nimas Sinha. The marketing director. So I request all our participants and other with their friends. Next week we will communicate through the WhatsApp, through this email and all. I require all of you to we thank our today's speaker for an excellent talk. Now I move to the next agenda. I call upon Dr. S. Karupasamy, our former chairman, and he is also representing our state, Tamil Nadu State Center as a committee member. I request him to propose vote of thanks. Over to Dr. Karupasamy, sir.
Yes, Mr. Selva.
Sir,
good evening to all. Yes, good evening to all. Am I audible?
Yes.
Yeah, you are audible, sir.
Am I audible, Selva? Yes.
Audible, sir.
It
audible,
gives
sir.
me pleasure to. It gives me pleasure to propose vote of thanks. So, on behalf of all the professional bodies who have jointly organized this program with the IEI Tiruchirappalli Local Center, Indian Institute of Welding, Indian Institute of Welding Society, Indian Institute of Metals, Kanyakumari Arivial Peravai, and Indian Institute of Industrial Engineers and ISND, I extend my warm and hearty thanks to our Nirmal Das, our West Bengal State Center chairman, who has readily accepted our invitation and presented a very informative and exhaustive and very interesting lecture today in additive and 3D printing through smart manufacturing. So we enjoyed your lecture program, sir. You have also covered the under Vision 2050, the various government initiatives and private industries initiatives and government policies and job opportunities available in the 3D manufacturing areas. So your lecture is very good and very interesting, sir. Thank you very much for sparing your valuable time and gave me a very interesting and current topic of the day. Thank you very much, Dr. Nirmal Das, sir. I also thank all the participants who have attended this program, large in number from all over India. Also, I extend my special thanks to all of them. I also thank all the members and office bearers of all the professional bodies. Thank you, one and all. Thank you, all of you. Thank you once again.
Thanks.
Thank you,
Thank
Dr.
you, sir.
Thank you for excellent vote of thanks. Thank you, Dr. So thank you so much, sir. Nirmal Das.
Thank you, sir. Thank you, sir.
Thank you, sir. Good night, sir.
Nirmal-
Thank you so much for your
Nirmal Das, sir.
Yes, sir.
Nirmal sir, thank you very much, sir, for sparing your valuable time
Thank
today.
you very much. Thank you very much, sir.
Karpasamy, past council member and past chairman of Tiruchi Local Center.
Okay, sir. Thank you very much.
Thanks.
Thank you, Gopalakrishna. Thank you.
Yes, sir. With the
Thank you,
permission of
thank you.
Nirmal Das, sir, we will close the program, sir. Thank you, sir. Good night to everyone. Good night.
Good night. Good night, sir.
Yeah.